Hello everyone, welcome to this presentation. This video is about circles, chords and tangents. Well, this presentation will represent lesson 1, which is about length of an arc. Length of an arc is just a review of what we ought to have known before we tackle chords and tangents. The intention of this lesson is so that by the end of it, we should be able to correctly state and use the arc length formula to calculate the length of an arc. Now, the requisite knowledge is we need to know how to calculate circumference of a circle, and we also need to know how to convert angles from degrees to radians and also from radians to degrees. To begin with, let's consider a circle, center O. A part of the circumference, that is a portion of the circumference like the one in blue, we can name it AB. That is what we refer to as an arc. So this is arc AB. So our aim is to learn how to calculate the length of an arc of any given circle. Well, let's consider this circle of radius r and the angle subtended at the center of the circle by the arc AB as theta. Well, with the radius and the angle theta, we can always determine the length of the arc as follows. The first case we will consider is when the angle subtended at the center by the arc is given in degrees. Before we get into that, I want us to note this. The arc length AB is a portion of the circumference, which is given as 2 pi r, and also the angle theta subtended at the center is a portion of the angle about the center, which is 360 degrees. So we can compare their ratios. That is, the ratio of the arc length to the circumference will always be equal to the ratio of the angle subtended at the center by the arc to the angle about the center, which is 360 degrees. Now with this equation here, we can express AB as follows. So AB is equal to theta over 360 times circumference. In other words, if you cross multiply, you end up with this, theta over 360 times the circumference. Well, you know that the circumference of a circle is given as 2 pi r or pi d, and therefore we can rewrite the formula as the arc length AB is equal to theta over 360 times 2 pi r. Now this is the formula we can use to calculate the length of an arc, like for this case, arc AB. And let's consider the case where the radius is given as 21 centimeters and then the angle at the center given as 60 degrees. We can substitute the following in the formula, and therefore we have AB is given as theta over 360, that is 60 over 360 times 2 pi r. Pi is 22 over 7, radius we've seen is 21. So we multiply by 2 times pi times 21, and that should give us 22 centimeters. Now that is how we calculate the length of an arc when the angle is given in degrees. So we make use of this formula. The next case I want us to consider is when the angle subtended by the arc at the center is given in radians. Well, I want us to note here that when you are given angles in degrees, we can convert them into radians as follows. So we know that 360 degrees should be equivalent to 2 pi radians. Now this will help us rewrite our formula for easy calculation. We know that the arc length AB is given as theta over 360, but 360 is now 2 pi because we're looking at the angle in radians. So we have it theta over 2 pi radians times the circumference. Circumference is still 2 pi r. And therefore, AB is given as theta over 2 pi times 2 pi r. 2 pi is common here, so they can cancel out. And therefore, AB is given as theta times radius. And so, here, theta is the angle in radians. Let's consider a case where the radius is given as 35 centimeters, and then the angle subtended at the center by the arc AB is 9 radians. Now, if we substitute this in the formula, we'll have the arc length AB given as 9 times 35, and that is 315 centimeters. So that is the length of the arc when you are given the angle in radian. That is the angle subtended at the center in radians. Well, with that, we look at the lesson in summary. We've learned that when the angle subtended at the center by an arc is given in degrees, we can calculate the length of the arc as theta over 360 times 2 pi r. And also, when the angle subtended at the center by the arc is given in radians, we can always calculate the length of the arc as theta times the radius, where theta is in radians here. Here, theta is in degrees. Well, with that, we can now try this. Find the arc lengths when the radii and the angle subtended at the center by the arcs are given as follows. Let me know your answers in the comment section. And if you found this video useful, please don't forget to subscribe. Don't forget to like. Make sure you turn on the notification bell so that the next time we upload our next video, then you'll be notified. Thank you for watching and hope to see you in the next video. Bye.